All right, everybody. Welcome to our volcano update. I'm Philip Long. I'm here with Dane DuPont. We've been giving you guys volcano updates for a while. It's been a little while, but there's been some recent signals we'd like to talk about that are being talked about on social media. So we thought we would get to it and talk about our two volcanoes here in Hawaii Island, Mauna Loa and Kilauea. Interesting that today, Dane, Mauna Loa is a volcano that's at yellow alert, and Kilauea is the one that's at green alert, right?
Right, yeah, that's kind of an interesting thing when we're going to get through this a little bit, and you'll see kind of why we were talking about why Kilauea might actually need to come up to yellow.
Yeah, that's right, yeah. So, I mean, most of our time today will be spent on Kilauea, but we'll start talking about Mauna Loa here for you guys. Let me kind of just maybe make sure there's a chance for you guys to join in. Yeah, hopefully you guys are all caught up by now, yeah. So Mauna Loa, we're going to talk about the earthquakes first. We have here on the screen is a map of the earthquakes over the past month on Mauna Loa summit, right? And there's not a whole lot of stuff. There's a little cluster of these kind of orange reddish ones in the past day, that they're basically kind of shallow earthquakes. To the northwest flank, northwest of the summit of Mauna Loa, that's one of the spots where it's always been popping off. So it's actually kind of slow. Maybe I'll click on the data for the last year so we can kind of see in comparison how that fits into the pattern of the last year. And you can see there's been a lot more earthquakes over the last year than we're showing just over the last month. So it's really kind of been fairly slow over the last few months in Mauna Loa.
Yeah, Mauna Loa is kind of in the same spot it's been in for a while now.
We can kind of see here this plot of the earthquake rates and depth for the past year, showing in the blue bars how many earthquakes essentially every week. And you can kind of see that's been a sawtooth pattern, up and down, up and down. We had a kind of a spike around late August, mid-October, something like that on Mauna Loa. This is just around that summit area. And it's kind of been fairly level, if anything, a little bit lower in the last few months, yeah. One thing that did come up was an update that we did along with Ikaika maybe about a month ago now, that followed the earthquake flurry on the Kīlauea fault zone, closer to Kilauea and closer to Volcano Village, but historically linked to Mauna Loa as the junction, like where those two volcanoes they kind of sit and rub against each other. So they can kind of affect either way that the pressures on Kilauea or Mauna Loa, either one can set it off or be adjusted in relation to that. So can you maybe help me recap that Kīlauea earthquake, Dane? The earthquake swarm series?
It lasted for only about a day, and it was just a quick little flurry in there, and then it kind of died out pretty quickly. It seemed like more normal aftershocks between the two, right? Because it was right near the golf course.
Right. So yeah, that's something that we've been talking about. What's gonna be the next event on a volcano? Is it going to be on Mauna Loa? Is it going to be on Kilauea? We've always said that Mauna Loa typically has something like a Kīlauea foreshock before something big happens. That didn't classify. It wasn't a big enough earthquake for that, but it kind of still has kept our focus on Mauna Loa to some degree. Whereas we were talking even at the time about how that Kīlauea could have also been an adjustment of Kilauea actually pushing against Mauna Loa, and maybe it's doing the driving right now. Mauna Loa is actually still reacting in a sense to what happened since 2018, right?
And with that, we can kind of get into the meat of this, the Kilauea aspect of this whole story.
Well, what we can see on the GPS of Mauna Loa, though, right? Like ever since the Kīlauea earthquakes, is that the Mauna Loa GPS at the summit has reversed trend, right?
Right.
This is being called just like a brief interruption, a slowdown, a pause. A long-term trend of inflation is still valid, right? This doesn't change any of the long-term outlook or forecasting on Mauna Loa. It just seems like something. It maybe gave it a chance to catch its breath or something, right? But really, like Dana's, chomping at the bit to get to Kilauea, because Kilauea is really the story. You guys are probably all tuned in today to talk about Kilauea. There's been a tilt signal on Kilauea, which is really interesting, right? And so that's kind of the bigger story here. But the GPS is noteworthy on Mauna Loa. It's something to keep an eye on. And we'll see, it seems like it might be resuming its trend. And if not, then we'll have to look on a longer term what's going on there, yeah. But right here, let's switch to the Kilauea signal. So right here we have on the screen an image at the top. This is the Uekahuna 2-day tilt, right? And let me see if I can get it bigger here for you guys. It'll come in a little bit bigger here. And the important thing to see is here the scale on the side right. Our microradian scale is going from 15 at the top to -10 at the bottom. So we started off yesterday at somewhere around, I will call it -8 range, something like that.
Right.
And it kind of climbed up to the range of, I'm losing my, to -5 or so, right in here. Right, and then it jumped up. I better zoom out here so we can kind of see the whole picture now. Jumped up right here at around 1800 hours Hawaiian time. Right, it jumped up from this -5 range up to a +5, and it's been increased like another 5 since then. Right, it's not a very steep climb right now, but it is a very significant as far as the scale of it. Right, this is something that we kind of can't dismiss as a like a pebble rolled over, or like it seems like something actually happened, right?
Right.
Someone kicked the station. Yeah, we'd like to consider those kind of possibilities as well, right? So this is just one station right here. So of course we're going to look at more than just one spot. So we have some other tilt stations around here, and this might be kind of small. Let's see, but this is the summit signal for the last month here, so you can kind of get a comparison, right? The blue line is what we just looked at, doing this big jump here at the end. So you can kind of see these are the inflation deflations, these up and down wiggles we have going on through here. They've been happening all throughout the last month. We've had 10 in the past month, and that's kind of back up from what it was before. But really, the big signal here is this big fat one, this big fat increase at the end, where it's kind of leveling off here at the top, right? So that's at the summit with Kahuna, right? There's a raw signal there. If we look at the Sand Hill Station, which is kind of south of there, we don't see quite as big a signal there. Now, of course, this is a station that has some caveats that we during eruption learned had some flooding within the borehole, and it might make the results unreliable. In fact, it looks like there's some drift going on here. That's the scale of this one is also pretty concerning, from -10 microradians to +10 across the 2 months, right? So there's some other kind of drift happening here. But if we focus in on the end here, maybe there's a little signal right there, a little drop, something that happens that's, not nearly the magnitude as what we see. Yeah. But, maybe worth considering as well, right? So if we look farther over, we look at the escape road, we don't see anything there. We don't see anything at Pu'o offline. There's nothing on a rift zone showing with these tilt stations, right? If we look further over, like on the South Flank stations, nothing really there either. There is one station, which is a station that's normally offline. The Summer Camp SMC station, which you can see is got some really spotty data, right? And it's really kind of hard to trust the station like this. But interestingly, it stays online the last 2 days, and it shows some kind of signal, which looks to corroborate what we see on the Okahuna station. So
if it was just one station, then it'd be easier to discount. But even this station, even though it's unusable, basically, in this one instance, it was on at the right time.
It's
you
definitely
see all those gaps from where it's off, like where it turns on, turns off, turns on, turns off the whole way. So it's been off more times than on this month.
It's definitely curious for sure, right? It makes us believe that someone didn't just kick the station, because if we see a possible signal, maybe 1.5 stations, maybe a smaller signal in another station, that makes us believe that something actually happened, but maybe it was more localized. It didn't happen all over the place, right?
Right.
So
we're still talking summit of Kilauea right here.
Yeah, and
all the stations that show it's in the summit or around the summit.
One important part of this is the earthquake pattern, right? And so here we have the earthquakes. This is over the past week only on Kilauea. You can kind of see that here is the summit caldera, and right in here, this is the area where all the earthquakes are. We also see a big finger down the East Rift right in there. Let's see if I can maybe I can get my pointer going here, because that might be helpful for you guys.
Yeah, so, the drawing device.
Let's see if I can get this thing here to draw, and there we go. So okay, that's now where I was going to draw. So here, that's working. Here is our summit area right in here. where all the earthquakes are happening, and this little arm right in here on the Upper East Rift Zone is also present, right? We have kind of a little cloud right in here of where all this pressure is building. We still have Pahala happening. It's still happening in the background here in the southwest, right? You can kind of see our south flank earthquakes happening. Our rift zone is right over here. So all these ones to the south is all still the south flank moving to the south, all through here. You can see it's going as far as Kalapana. We don't really have much of anything over here in the Lower East Rift as far as earthquakes in the last week, right? It's been pretty quiet as far as that goes.
Phil, you're gonna have to redo that section. I think it's a lag spike.
Okay. So yeah, sorry if I cut out you guys, but talking about this summit cluster of earthquakes right in here, to the summit and the Upper East Rift right in here. Right, that's the earthquakes over the past week. We have the East Rift Zone in this direction right in here. And so we have all these other earthquakes, are all south flank earthquakes, the south flank moving to the south, all through here, right? All the way to Kalapana, you still see a little bit of that action. And then a whole bunch of nothing, missing earthquakes over here in the Lower East Rift Zone,
yep.
Right? So that's the past week pattern that we're seeing. And let's see here. If I go back the past month, and let's let that load up. And give it a zoom in here so you guys can see the past month data. Right, you can see we still have our summit cluster right in here. We have a little bit of a southwest rift zone, a southeast rift zone. Looks like a little fork right there, right? We have a little cluster up in this area. This is a Kauiki earthquakes, kind of the tail end of the aftershocks of that sequence. You can see we have more adjustment on the south flank, especially in this middle part of it right here, kind of between Mauna Ulu, which is right in here, and Puo'o, which is kind of over in this area right in here.
There-ish.
So you can see that a few earthquakes down here in the Kalapana and the Lower East Rift Zone area, but not as many as we have in this upper area over here, right? So the south flank is definitely still a big player, although I would say that overall, maybe it's worth going back to my past week over here. Overall, I think there's less earthquakes in the south flank than we've had in quite some time, right? If you look at just the 1 week picture right here. It's still active, it's still moving, right, but it does seem like it's slowing down a little bit, right?
And it's mostly the upper, the part of the south flank nearest the caldera.
Right, exactly.
Directly south of that, that's moving more, or quaking more than further down the route.
That's right, yeah, this area.
This has kind of been what we've been seeing, since the end of the eruption, was that it was working its way, the quakes diminishing back towards the summit over time. It's a slow process. That's why they were, up until recently, they were still referring to the earthquakes on the south flank as aftershocks of the magnitude 6.9 on May 4th, 2018. So 2 years later.
Right.
Because of the movement. But it has been slowing, is what we're suggesting.
Right. And it's a hard pattern to see, because if you look at just the earthquake rates and depth, this is a past month. So, when you ever look at the past month, it's always going to have ups and downs, because that earthquakes don't really fall into that kind of pattern, right? So what we'll do is we'll go to the past year data here unassigned and compare to the past year and look at some of the differences, right? So you can kind of see in comparison, the past year, there's been a lot more earthquakes in this Lower East Rift Zone area right in here. Right, we're missing those in the recent month, right? But what I wanted to show you guys on this page, if we kind of scroll down to see the earthquake rate and depths for the whole past year right in here, there it is. You can see that we are at this right end of the graph right in here. It's a little higher than it was the last month, but it's not as high as the Kauiki earthquake flurry in October, and we're actually at a similar background rate as we've been for a while over here, right? At least in September, and not that far off of what you see much of the rest of the year, right? This is if we zoom out one more time, I'm gonna go back to the 5-year plot. If I scroll back up and go to the 5 years data right in here, and then go back down, so you can really see the 2018 eruption as well in this plot, right? You can kind of see 2018 eruption earthquakes right here, that massive record-setting event. Background level before, it's pretty low. The background level afterwards continues to be higher, right? And so the earthquake rates we have now are a little higher, but they fit within this elevated background pattern that we've been seeing for a while. Right, so that's what I want to show you guys there. So, diving into the earthquakes a little more, we can kind of go to the Kilauea page, the HVO page, and they have a monitoring map, and it looks like this. You can zoom in and out. It has all these different instruments. You can click on each one to get the signals of the GPS, or the tilt, or whatever else. This is the main way that USGS provides to interact with their data. But I wanted to zoom in here and give Dana a chance. Yeah, no, I'm going to give it to you, man. I just want to zoom in here and let you direct me how to make this map appear.
Right. So one of the things about here that immediately draws the eye is the focus of the earthquakes in the middle. This little swarm by the sulfur bank, or the bluffs over there, on the south side of the caldera, right, kind of where you can walk out and see if you go to the national park. But the interesting spot there is just these small continuous earthquakes in there that have been coming in the past 48 hours, right? And the thing that's also interesting about that area is this magnitude 3.1 just to the south, where that we were talking earlier about this 1800 time frame where the tilt signal happened, where a few other things that we're going to get into happened we haven't shown yet, but this quake is right at the time.
There it is.
1800.
Yeah.
So that was whatever is going on there. It started at this 1800 yesterday. And we've been seeing stuff happening from there. Things have been building up into this point, but that one event, as we'll show you when we get into the seismic data a little deeper, kind of shows that something's going on here. And you can see these lots of small little quakes in the past 48 hours. A lot of them since this 1800 signal.
Yep.
And a lot of these are just really shallow. I mean, we're talking about a depth of between sea level and 1.5 kilometers down, or 1.5 miles down.
Yeah.
On this one.
Yeah.
And everything's kind of falling within this range. So these are really shallow signals that we're looking at.
Right. I just outlined that upper east rift zone arm. You can kind of clearly see that pattern of earthquakes even in the last few days right here. Right, we see a little hint of the southwest rift arm, but it hasn't been nearly as active in the last week as it was before that previously, that we kind of saw in the past month image of earthquakes. You see a cluster. This is kind of the deepest pit of Haleʻimaumau, is kind of right in here, near where the water pond is at this western end, and you kind of see there's a cluster of earthquakes over there. Silver Bank area, there's kind of right in the middle, kind of a clustering in there as well. And of course, all these earthquakes are preliminary results, and so they might move around and get look at it and get more focused and refined over time. This is kind of our first chance to look at it and see what we can kind of glean from it, right? But yeah, so one thing you can do with this USGS map is you can click on any of these circles, or I'm sorry, these little triangles for the seismometers. Like for this one, for example, is let's pick a different one. Let's pick this RIM digital station. You can click on the instrument information. It'll give you the seismographs, right? And so in this case, for the past 48 hours. So we can go back to yesterday when this earthquake happened at 1800. And curiously, right here at the 1800 timeline, right? It says 1800 right over here. We have this band of elevated seismic activity, right? And it kind of looks like it starts picking up. It's not quite clear exactly what comes first, whether it starts shaking and then that big earthquake happens. That big earthquake looks like it's right in here, actually, right on this graph, right in here. So there might have been, some other smaller earthquakes building up to it, but there's some kind of harmonic tremor in there that appears almost like something like you would expect if magma was moving through some small conduit underground, like so. It could be like a small dike that's kind of under the caldera somewhere. There's a special kind of everyone knows the word dike now from 2018 eruption, but there's a special kind of dike that we call a sill in geology, right? The dike is like the hand, the fingers come up and down, right, like this. The sill comes in this way, flat, right? So it kind of comes up and just wedges itself in between two layers of rock, and it kind of pops the other layer above up and kind of just open itself up like that. So that could be something like that. These are some very small scale events, because as we've showed you guys already, we don't see the signal anywhere apart from this very western caldera stations, and we'll talk about that in some more detail.
Yeah, the tilt signal in particular, because the seismic signals, and when we start talking about the GPS signals, those start reaching much wider than than just the summit.
Right.
Progressively.
So I'll put some thumbnails here of like a lot of the seismographs from the summit area, right? And so you can kind of get an idea that, you know, this band is kind of solid band that's in the middle, right in here, is common in lots of these stations, right? So it's something that actually occurs all across. Some of the stations are a little wonkier. This one might be out of calibration. It's hard to really tell. This one's got something going on. It might be near the source, and so it might be showing more combination of various effects, not a pure seismic signal. It's hard to exactly tell there. The outlet station right in here is really interesting, right? Because it actually shows that 1800 band, and then something different starts happening. Like it induces some other action or settling in that area, or movement.
Just to show how crazy it gets, because you got to see it. It's fine up until 1800. Everything's kind of calibrated, looking good. 1800, you get this tremor, whatever's happening at 3.1, and then it gets really wonky for a while. And it could be calibrating it, but it's definitely not as. It has more noise in it now. Had some kind of noise introduced into it. Right,
and you know that could be, you know, if there are small rock falls in the area, or, you know, other kind of noise. You know, people, and, you know, this signal right here is in the middle of the night, so we don't expect it to be traffic or anything like that. But there could be other signals. You know, wind can sometimes put signal on seismographs, and there are other effects that could be involved, right? But what we're seeing is a common signal, this main band at 1800 hours, kind of across all the signals here. So you don't see much of that. Like, you know, if you look at the East Rift stations, they pick it up, right? They see all the earthquakes are happening, lots of earthquakes in Upper East Rift. Not so much of the tremor, maybe picking up from far away. It's harder to really tell with this kind of really broad kind of top level without much refinement analysis. Look, we haven't like gone in and done any math in any of this seismic signals like the seismologists will actually do to figure all this out in detail and actually come out with more information for us, right? So that's what we have for the seismic signals, right? It's not really clear exactly what happened. Whatever it was didn't last very long. These bands are from left to right across the page. It's about 15 minutes. So if it takes 2 bands, that's 30 minutes. 3 bands, 45 minutes. It didn't last more than an hour, whatever it was. You know, that particular flurry.
Question for you: in a typical pre-2018 eruption sequence, and you saw the tremor, how long would that last if you were leading into an eruption?
Well, so I mean, normally you see more of the earthquakes before the earthquakes being the magma or fluid preparing to actually move, and then the actual tremor is it's actually moving at that point already. So you wouldn't see it actually showing a tremor unless it was actually magma was actually flowing. Now we've had magma flowing at the summit of Kilauea since 2008 when the pit opened up, right? So that's kind of always been obscuring ever since then. And you can also have other fluid like gas can have similar kind of signals. You know, these kind of signals have occurred before now, even in the past year, with things that have been moving around. There have been bands that have appeared, right? You know, we're just kind of trying to see what's happening right now and how that might actually be different than before. And so it's hard to say that anything really changed underground with that. It could have just been adjusting it in the same way. But, you know, it also could be something that we're looking for. We're looking for something a lot longer than that, though. So it's not like a real major event, no matter what it was, you know, at least on its own as of yet, right? But the fact that there are so many earthquakes, right, and, you know, you do see, you know, so much tremor, and you know, is interesting.
Right, and also the depths of those earthquakes and the exact locations of them. That's where it starts to get extra interesting. If it was just the tilt signals we were looking at, and we just had this tilt bump, then it's tilt, and without something to collaborate it, it's kind of hard to use, or really hard to use. When we have this earthquake signal that's so clear that something is happening there, it becomes easier to, you know, to talk about what is happening on tilt, what is happening on GPS.
Right. And so here's our earthquake seen a different way, right? Now we've gone to the USGS monitoring page and used their earthquake plots tool and kind of drawn a box around a caldera and Upper East Rift, and kind of on the bottom part here, this axis down here is time, right? So this is midnight, and looks like this is about a week plot, right? So what this is showing, and on the left side, this is the depth going down, right? With basically right up here being the surface, somewhere right in here, this being sea level at 0, And here is the bottom of the rift zone, and the upper magma chamber is somewhere right in here. This is that 1.5 mile down range. So you can kind of see that all these earthquakes fall neatly in this upper area where we see all this kind of activity in the upper east rift, the upper chamber of Kilauea. So one possibility is, we've had something happen that's inflated the upper chamber of Kilauea. Maybe it's being fed from below, or maybe the spreading of the volcano as such with the south flank has made more space that's induced magma to rise into that area, that shallow magma chamber. This is all things we've speculated on before. We don't really know for sure. The overall indication is that magma is filling Kilauea, and it is swelling more, producing more earthquakes, right? Especially in that shallow range, to the point where it might actually, coming back to what I started off talking about Mauna Loa, might actually affect that Kawiki junction between Kilauea and Mauna Loa, to actually push back, and maybe undo some of the movement that was done during the 2018 collapse, which was all sagging and basically letting go of all the pressure, that was pushing against Mauna Loa. Everything drained away. Everything kind of sagged into Kilauea, right? So now we're reinflating. We're kind of having to make more elbow room on the sides and kind of wiggle past and kind of overcome that friction to push Mauna Loa. Maybe that's what the Kawiki thing actually was, an adjustment to Kilauea, and Mauna Loa is actually, just responding.
And you can see there the yellow earthquakes earlier in the late last week, I guess it would be.
Yes.
And that was also a little flurry inside the caldera, but it was a slightly different location. It was more north towards the northern edge of the caldera. Now we're looking at southern. So there's some changes going on.
Yeah, certainly there are.
All right.
So, okay, and
I think the GPS is really where it starts to, you can start to see the story being told of the change happening.
Right. So yeah, we'd like to show you guys lots of data, because we don't want to kind of be talking, blowing hot air. Kind of show you guys what we're looking at, and kind of have you guys understand where we're coming from, right? And you can agree or disagree, or look for more information, or especially we await the USGS to kind of chime in and see what they're going to say. But we want to make sure to not delay, because this is kind of the story spreading, and want to kind of get back on a horse here, right? So the storage, we have all these GPS stations, 2U GPS from across the caldera, but I want to kind of start all the way down at the bottom of the East Rift Zone, where the Jonica station, has been out of commission since October. But you can see that before it went out of commission, you can kind of see that in all, kind of to help you guys recall what these plots actually are. It's a GPS signal. The north panel right here is showing the east component. So when the thing goes up, it's moving east. When it goes down, it's moving west. This middle plot is showing the north-south. So when it goes up, it's moving north. When it goes down, it's moving south. And this bottom one over here is showing the up and down. So when it goes up, it's moving literally up. And when it goes down, it's moving literally down as well, right? So all three components of this signal have been adjusting since 2018. We can show you more historical plots in the future, but you can kind of see there was a adjustment from April to June of this year that happens across all three of these. But then after that, it stabilizes, and it's been almost flatlined on all three components of GPS at the Jonica, right? Ever since, in this case, let's call it July 2020, right? So whatever has been happening at Jonica, which is the farthest east station we have, the closest to Leilani. It's not that near Leilani, but it's the closest one towards Leilani.
Between Pu'o and Leilani, like about halfway. It's pretty close.
Yeah, that one is showing signs of stabilization. So the next series we have over is the Jacuzzi and Pu'o station. So this is the Jacuzzi, which sits south of the rift zone. So it's got some possible south flank effects, right? It kind of does move to the south, right? It maybe is slow down a little bit moving to the south, but what's really interesting is you can kind of see back in April, it switched from having a westward movement to an eastward movement, and that's okay, and then things wiggle around. But here, especially here at the very end, since October, you can see that this rate has been much higher, and that's curious on its own, and maybe something localized. You might say, well, I've in the past described how there are a lot of local effects around the East Rift Zone, and you want to make sure that signal is consistent across many places, and not just something localized in one spot, right? But what we've noticed is that the thing is moving east a lot faster, and it's basically ceased its up-down and its north-south motion, right? So we're not don't have to go into this much detail on every single one of them and kind of show you guys the pattern of it. But if you look, Mulivaio Pele stopped recording before being useful. North Pool Okon, right? Since October, stop moving north, stop moving up, moving east much faster. Okay, that's the North Pool station. Oh, I lost my spot.
You're going to start seeing this over and over across most of the stations that we're looking at, especially the ones that are in the anywhere east of Caldera.
Kamoamoa, moving east faster, stop moving north, stop moving up. Kananoyo Hamo.
Is that one?
Sorry? That was
just give a general location of them.
Kananoyo Hamo is by Makapui, 11 miles. It's about 11 miles east of the summit, right? About 7 miles east of the summit on the rift zone. Kananoyo Hamo is moving east instead of moving west now. Right in there. Stop moving north. Stop. Slow down moving up. Right? Okay, Mauna Ulu.
Just at the bend, right?
At the bend, yeah.
Close to the summit.
Starts moving east much faster. It's hard to tell what's going on here with the north. It might be slowing down. It might not be. That's questionable. Maybe nothing's changed. It's hard to tell. Mauna Ulu is also kind of closer to that area of the south flank that's really moving. So that's a question mark here. And we have a smaller scale here and more scatter. But I don't know what's going on. Possibly.
The thing about these plots is each dot is a day. So it would take some time for the signals that we want to see right now on these 2-year plots to see them to actually come through. Normally, when we've been looking at these 2-year plots, we don't like using the edge of it, the last 5 days signals, because there's a little extra variance in it. It seems like you start to see a trend, and then you're like, never mind. After a week later. But on this one, you can see it's been holding this trend change consistently for weeks.
Right. That's a great point. Yeah, great point. This is like a chance to zoom out and look at the bigger picture, because we can't see the detail of what's happening in the last day or last 24 hours, even the last week. It's more about what's been leading up to this. What's the context of what's happening? And since it's been a while and we see this change in a lot of these stations, it's worth pointing out. If we look at the stations around the caldera itself, we don't see that, right? We don't see the station at Wikahuna moving to the east. It's not moving east at all, right? It's not showing that much of a signal at all, in fact, right? This is where maybe having a 1-day signal or 2-day signal might be important, because we can't see what happened with that tilt signal. There's nothing corresponds to it on this plot, right? But it might not have the scope of it. The outlet station, right? It's maybe possibly changed this easternmost trend, but it's actually moving slightly more west, right? That's not fitting in a pattern. But those are the stations that are the ones that don't fit in, the ones that are north and west of everything else, right. That are not fitting in, right?
So it's like you could take a line and draw it down the map, and from there, things are moving east. Everything east of there is moving east. West of there is not moving east.
Yeah, exactly, yeah. So that's what's basically happening with it. There's nothing major on a GPS. Essentially, you guys can see that the patterns have basically changed, though, right? One thing that's interesting is if all the East Rift stations are getting pushed to the east, right? They're getting pushed from the west. That's essentially that kind of southeast caldera area that we've been discussing, right? That right. Correlates to where the Earth 3.1 was recently, where that tremor band kind of was associated, and with all the flurries which are happening recently, right? So it could be that most of the rift zone is now essentially, might call it locked in, right? Where it's adjusted and it's kind of restabilized all the way back from what happened in 2018 to the point where now what happens at the summit is what's driving the game. And if it comes back and starts changing the rift zone, we might have to be on a higher alert than before, because now the rift zone is more stable than it was, and the summit's less stable than it was. Right.
Right now, we don't see that signal coming down the rift. It's just at a point where it may be more in a stabilized equilibrium state where it's not refilling.
Right.
As we've been saying, now it might be refilling in that section.
Right. These are the south flank stations here. You can kind of see they have little bumps to the east as well, a little on many of them as well, and a lot of them are moving to the south as well. But the interesting thing is some of these stations are actually moving to the south faster in the last few months than they were the few months before that, right? So that's interesting. It's the south flank is certainly an important consideration in this whole discussion, and it's not clear to how much of an effect it's having, but certainly in that area, right? We can look at Devil's Throat area, which is kind of a connection zone between a summit and Upper East Rift, right? And you kind of see that it here has had a steeper trend after having a flatter trend that kind of follows a steeper trend following eruption, right? So certainly there's some give and take with the movement of the south flank there. That's something to keep an eye on as well, right? So that's most of the GPS story. We can go back to the top here and just show you guys what the summit and East Rift look like on a differential plots.
These ones are measuring a distance between two stations, right? So if it's going up, it's getting wider, the gap between them. And if it's going down, it's getting closer. They're getting closer together. First one on the top there is measuring from the north side of the caldera to the south. So it's giving you a north-south measurement. And the one in POC and Jonica, further down by Pu'o'o, that one's also measuring a north-south, but that one's measuring an interesting one because it's crossing over.
Right. So the rift there seems to not have been spreading in the same manner as it was before, right, between North Pu'o'o Cone and Jacuzzi. And it's hard to see, this is one of these GPS, the last few data points in the day, we can't really see what's happening at the right end of the plot, but you can kind of see there's nothing really that changed in the buildup at the summit distance to whatever's happening now, right? So we're still basically still building, still cooking. It could be that it stays pressurized like this for a while, right? In the past, I've Pu'o'o era days, remember there being elevated earthquakes in Upper East Rift Zone for between 2 weeks to 2 months before something actually popped, whether it was a new vent at Pu'o'o or a fault, an earthquake that allowed like some pressure relief or something else had to change, right? So we're getting into that range now where we're seeing enough different things that it's kind of like, well, this is being dynamic in a different way, and that's being less dynamic, and this is being dynamic in a different way that, as we started off talking about, maybe we should consider, and we wouldn't be surprised, Dan and myself, if we saw Kilauea bumped up to a yellow alert level at some point pretty soon. We think the potential is there for nothing major to happen, nothing major. Something's, it will be something small, likely be in the park, likely in the caldera, if not in Upper East Rift in the park. Likely very brief.
But one thing that's worth mentioning is kind of the scale of all that we're talking about in terms of, well, not the scale, but the how the dynamics change following the 2018 eruption, right? The USGS and many of the people that were living around it and observing, watching the volcano for the past 30 years got really comfortable with it in terms of knowing what signals meant and what they didn't mean at any particular time when it started, churning or magma started moving. We've had to reassess a lot of different apparatuses or a lot of these different equipment and how they read and what the interpretation is following the eruption because so much changed. And we're still we're not saying that it's definitely building towards something. There's still a giant asterisk there of this whole thing has changed. This whole game has changed in a lot of, so it could, take more than a few months potentially, but it could also be, the same signal that we're kind of used to and kind of more know, and it could be a few weeks. We don't know.
Yeah, so it has to basically adjust itself in response to that whole thing. You're absolutely right, Dane, right? And there's different ways that can happen. One way that could happen is actually just swelling itself and pushing everything that's above you and to the side of you outwards and just pushing it back where it came from before it collapsed, because all those blocks are separated by faults and it can all still move. So if you get just the magma chamber can just swell up and just push things back. That's one way, right? It can actually then inject into something else, and that's another way it could actually move things back, is by actually moving the magma itself into somewhere where it hasn't been and pushing things out that way, and then refilling it by putting lava into an area that is now air. Another way it can restore itself, right? But it can do some combination of those things. It can actually move and sag and settle and fill and change shape all at the same time, which is what we're seeing it happen now. And so it doesn't mean that this is going to erupt. What we're seeing is a sign of it's actually building pressure, and like how that pressure is released one possibility is eruption, but it's not the only possibility, right? There could be intrusion where it actually injects underground, never makes the surface, or it can just like swell a chamber and move the faults back, which you'd see as a bunch of earthquakes, and actually restore its old shape by doing that, right? And it might leak out once in a while through a sill or dike, or possibly a small eruption. But the overall pattern is one of it's basically refilling, long-term refilling. That doesn't seem to have changed, There were some questions right after the eruption, like, well, how long might it actually last and take before it can refill? And so here we are, and it seems like it's full to the point where it's pushing back all the stuff that collapsed before.
Seems to be the case. Just the question is, how much more pushing does it have before it squeezes something out to the surface?
Right.
And then we get into the whole new dynamic of when it squeezes to the surface, how does it interact with a now standing lake inside the former crater?
Right.
And there's some dynamics there for explosive eruptions, and what dynamics would lead to one, what scenarios would not. And that's kind of a whole other thing. We can maybe do a special episode on that. We're not really prepared for that kind of thing today. We're talking more about, what are these preliminary signals, these super preliminary signals that could warrant changing Kilauea's status. Now, the thing about Kilauea's status is green on Kilauea up until 2 years ago, it was never a thing. Since the system was made, green never was found, right? Because Kilauea is always stirring, right? And then we found out in after 2018, we defined what is background levels of activity on Kilauea, right? That the only time that we've been able to determine that is when there was no activity, which was the only time recent modern history when we have the technology to actually monitor this thing was the last 2 years. So now we get this spur of activity. Okay, so we're now in uncharted territory. HVO has never had to raise from green Kilauea to yellow, right? They've gone yellow to orange a bunch, orange to red a bunch, but that green to yellow, that's new. Right, and that's kind of where it's worth discussing, because it's, again, what does constitute yellow? In the yellow, you can sit in a yellow for a prolonged period of time. Mauna Loa shows that one very well, because it's almost it's been in for the past 10 years in a yellow state, except for a brief point where it got brought down to green and then brought back up to yellow. So you can sit in a yellow. And it's really about how HVO feels like just defining this on what is a green transition to yellow on Kilauea. What does that look like? What signals do you need at a minimum? And how early do you want to do it? Right? Because the one thing you don't want to do is just be like, oh, okay, yeah, we're going to bump it to yellow, and then the next month it's really, really quiet up there. Right? So you got triggered by something too small, right? So it's that balance, right? And it's obviously it's not our choice to make to raise that alert level. We're just saying, hey, you guys might want to start talking about it, right? Find when you want to and when you don't, what the signals you want, and help the public understand that. Because you remember how the media portrayed the raising of from green to yellow on Mauna Loa. It was like newsworthy. It's like, no, it's kind of going back to the state of it's slowly building. Sometimes something might happen, right? It's really not that big a deal to go to yellow. So it's about the communication and defining it and making sure people understand why it's being raised and that what it does and what it does not mean, right? You can say right now, like if we were to argue it was going to be raised to yellow, that'd be at the summit. We'd be raising that specifically at the summit, around the summit region. It would not be down in the lower East Rift Zone where the 2018 eruption happened. There's no indication of that. But at the summit, you might want to start talking about it. Go through your protocols. If you're the national park, it's going to be a little bit different this time because now you have COVID concerns, right? And you have protocols in place at the federal level that you have to abide by. So it might be time to plan it out a little bit.
Yeah, for sure. Yeah. So that's absolutely true. I mean, we're just talking about that maybe the threshold isn't quite exceeded, but we're definitely the things that we're measuring the thresholds of are changing in pattern, and that's why we're kind of sharing this much information with you guys today, right?
Right.
There are some other signals to talk about on the summit of Kilauea here briefly. I mentioned the deflation and inflation signals, right? There have been 10 in the last month reported by the USGS. That is up. Previous month we only had 2 in October. We only had 4 in September. Before that, it was 12 and 16. And so, it's been up and down, up and down. The only reason that might possibly matter is because, we've kept referring to the one study which does show, does indicate that, or suggest perhaps, it does suggest that in times of no deflation inflation events, you're more likely to have eruptive activity or changes in eruptive activity, right? And it's not a super strong correlation, but it's the only thing we have to go on. So we keep that in the back of our mind. And so when we see the DI events climb back up to these kind of levels, we think, okay, well, it doesn't seem like something is going on, at least from that point of view, from wherever that signal is coming from. So, there's no change there as far as we can tell. There is no indication from that anything's widespread changing a volcano, right? And this, we'll call it localized change, to Uekahuna, possibly the western and southern part of the caldera, is something to kind of to look at in more detail. We do have Go ahead.
Kind of had a giant fork in the road in terms of what could happen here, right? It could be we do another update in 1 week, and we're talking about a building potential eruption on Kilauea. Or on the other end of the spectrum, it could be, oh yeah, remember that thing we were talking about last week? It stopped. Right? It's not doing it now.
It could be, right?
There's one of those points where we don't know exactly what happens. It's an interesting junction, though.
I've been saying Mauna Loa is going to erupt for, it's building eruption, and it has been, but we're not anywhere near there yet in Mauna Loa, right? And so Kilauea is definitely building towards an eruption, but we might be years away still potentially. It might adjust and adjust and adjust and adjust. To your point, Dane, right? It's hard to say how these things are gonna go, right? But she's certainly alive. There's a pulse in there. And we're all tuned in to the next chapter of the story here. And we do have a rapid GPS at the summit that we can look at nowadays as well. And it's hard to see much of a signal in these plots because there's a lot of variation just naturally through the signal capture. But there are a couple of these stations that are different stations between 2 different signals that are filtered, right? So this one, for example, is a east signal within the caldera. You can kind of see that the baseline, like the middle point of this blue line in here, might appear to be trending upwards a little, just slightly, right in there, right?
Like 10 millimeters in a week.
Yeah. It's hard to tell with this analysis, but just something to know. Just we're trying to see. There's nothing quite obvious there. That's nothing widespread in caldera. You can kind of look at all these different spots and see if something was in one particular place going particularly nuts, like during a collapse of the caldera, we would see that, and we see kind of the regular range, which is pretty noisy. I'll grant you. So we'll move on from that. Another thing to look for is gas, right? So the park's got gas stations all over the place, and you can kind of see here for the last couple of days, everything's been green. There's been no sign of an increase in gas at the park. Of course, the caveat is that a lot of that gas is getting trapped by that pond, right? Still,
It turns out water is a pretty good way to absorb SO2, and it's kind of buffering output and to an unknown degree. That still hasn't been quantified by USGS on what's the unfiltered base output, because we really don't know. The dynamics of the lake are still kind of hazy exactly.
Yeah, absolutely. Right. We're still kind of awaiting the chance to have more samples and more studies of the geochemistry so that, we can really say more about that. Right now we're just kind of in the dark about that. Here's the 2 SO2 signals at Park that the HVO has online. You can see one of them went offline a couple weeks ago. So this bottom one here, it's kind of flatlined right in here. No big deal. It's it's COVID. It's there's always station maintenance to be done, and so that's why there's multiple ones. This one over here is not showing any kind of change really any time before here. You might say, okay, well, if we zoom in at this very far end over here, right? Oh, my first thing I see is the station went offline, so maybe there's something funny happening over there. But before that happens, there might be an increase, like a small little increase happening right in here. Hard to really tell, right? But even if so, we're increasing from 0 to 0.1 ppm at most. That's kind of the range. This is nothing anywhere close to what we saw in 2018, right? Or even what existed before that with the open vent at Halemaumau. So,
and this is still at the historic levels, low levels of SO2, which presents SO2 measurements have been taken. How much of that is due to the water?
Right.
In some instances.
And so, speaking of water,
yep.
Here is a thermal image of that pond in Halemaumau the last 24 hours. And, there's not a whole lot of change in there. If I look at the scale bar over here on the right, the top value of this bar over here, that's what matters, right? It doesn't get any hotter than 90 at any point right here. So the pond doesn't seem like it got any hotter. We don't see any more heat in the walls anywhere. There's no sign of any lava or anything like that. There's no change on the surface you can see from the thermal image right there, right? And in fact, you can kind of go to the wide view here. Right, let's reload here.
It's kind of getting dark.
Yeah, starting to get dark. Yeah, a little bit of a sun flare in there, yeah, but you can see there's nothing obviously different up there. Everything's just as peaceful as always up in here, right? And nothing at night as well. You can see the moon flashing in front of there. So one interesting thing with the water, with that lake, is that we've been following the summit water measurements, the depth of it, right? This has kind of been a different kind of trend over the last month, really, than we had earlier on, right? Actually, the first 5 months of the lake being present, till January 2020, was filling pretty fast compared to now. Something like 4.5 meters a month. That's about 15 feet of depth it was gaining every month. These first 5 months, right? So that by the beginning of January, it was 75 feet deep, 23 meters deep. Right. Since then, if we kind of take all the whole rest of it all the way to here, right? That's all 2.5 meters a month, or 8.5 feet a month. So it's about not quite half the rate, but a lot slower than that, right? And not only that, the change from last month to this month was only 1 meter, right? Officially, I think it's just from November to December, and we can actually zoom in here. The right end of this graph, right? And so what they're saying is December was 49 meters, November was 48 meters. This thing has gotten almost flat. It's almost stabilized, filling apparently from these multiple measurements taken by the USGS scientists over the last few weeks.
The interesting thing about that is it matches the projections that we made, that USGS made, about how deep the lake would potentially end up being. And there was some variance on that because the water table in that area varies, and we've seen that since the two different visits to the Keller well just south of the water lake to sample the depth of the water table. It varied by, what was it, meters, like that, between just a couple of years. So there's some variance in there, but this was right at that level that we're talking about. The lake would eventually find some kind of,
right,
it's just that far below the water table.
Yeah, and it seems like, right now, the latest measurement, 49 meters, 160 feet. That is the depth of that lake. And so if that's what you chose, then you're the winner.
Yeah.
Right?
Volcano bingo.
Yeah, so that was a lot of water in there. Maybe now that it's kind of stabilized, it might be easier to do repeat sample and maybe do some more measurements on the buffering, the scrubbing of gas from that lake, which is an important part that we're missing from this whole story still, right? So that's most of the Kilauea story here that we have today. There's kind of one other aspect of it down in the Lower East Rift Zone.
Let's do some questions first before we jump.
Let's catch up on the questions. Okay, go ahead.
So, is we're just talking about the lake? So Nathan asks, is it half of the rate, or does the diameter of the crater expand more, making it appear as it's filling slower?
Yeah, that's a good question.
I would suggest immediately that it would be the rate of the expansion is very small on the north south, at least.
Yeah, I think probably early on, I think he does have a point, because early on in this early part, when the bottom of the hole is steeper, right, then you actually are, maybe it's more accurate how fast it's actually growing. That's maybe the middle part in here. I don't know. It's true that I was trying to find a measure of the area recently, and it's been hard to come across. And so I'm sure that'll come out at some point soon. But it's true that you have a larger surface area to kind of fill at the top there. Yeah. So, but the most interesting thing is that 1 meter is the smallest interval we've seen, right? And we look at these repeated measurements over here, and yeah, it's true we've had similar kind of clusters in the past, right? If we look like somewhere in here, you might have guessed it might have stabilized. If it looked like in here, you might have said something similar, right? So we still have to wait and see if it really is, but it is suspiciously close to that depth that we suspect it to stabilize at, and it does show some signs of possibly slowing, right? I mean, so just worth pointing out that that is something we're keeping an eye on too. But yeah, good question and good point as well.
Yeah.
Thanks for that, Nathan. What other questions questions about the gas?
Dallas asks, as magma fills, will the Lower East Rift Zone feel like a superhighway since it's so fresh and clear?
Well, so I think that the East Rift Zone has been refilling for most of the last 2 years, and that's the kind of the wiggly signals we've seen. But I wouldn't call it a superhighway. It's been more like a trickle, right? It's kind of like, like just like a gravity feed, right? It's like a gravity feed, just filling in the spots that are able to get filled without a whole lot of work. You fill all that area, and there is some question about how connected the rift zone is below Mauna Loa, right? We have seen, it seems like the signal is stabilized all the way past Jonica, like past Puo'o. So I suspect that if those signals start changing, it's going to have to propagate from up to down again, and not through a superhighway, but rather through some cooler rocks and new pathways, new earthquakes, new tilt signals, new GPS signals. I think we're going to see all of that all over again, rather than actually being able to shoot straight down there. I think it's been way too long for that to be the case.
I'll take the next one.
Yeah, I'm having trouble reading them on my screen, so if you can mind reading them all, that'd be awesome.
Yeah, Chris asked, could the slowing lake level rise be due to the increased water temperature, increasing evaporation? The thing about that is we have no real indication that the lake at Kīlauea has been increasing in temperature.
Right.
Even then, it would be interesting, but it's been pretty static. What I've seen ever since the first temperature measurements were taken.
Right. Yeah, so a question about about the sulfur signal and why it looks kind of so spiky. And one thing that's worth talking about with these gas signals is the wind direction, right? Like depending on where the source of the gas is and where the sensor actually is, you may not detect it at all because the wind's blowing it completely the opposite way. So you do have to have, ideally to have sensors in a ring around your source. You can tell no matter which way the wind was blowing, it was blowing one of those directions. So we don't have that, so we don't know that exactly for sure. We're just trying to catch glimpses of what the maximum might actually be. So those spikes may be that, a sulfur source blowing towards the sensor in optimal conditions, once in a while, because we do know that there is sulfur coming out of there. It's just not anywhere near the levels that we'd expect it to be for fresh magma coming up, right? We're not seeing any kind of spikes, and even these spikes are not really changing in their maximum values that much over time, right? So but I think that's a good point to say, we've been more aware of gas and fog as well because the wind directions changed more so in the winter. We're now in December. We have a different wind pattern on the islands, right? So we're more likely to smell any of the gas, and we might actually be smelling fresher gas because we do believe the volcano is filling with magma still through all these signals, whether it's earthquakes or GPS, right? So you could have some SO2 in some areas. It's not going to come shooting out of there. It's just going to be degassing, just like it has the whole rest of all our lives as volcanoes done, and all the lives of everyone before us as well.
Right, and then we have one other question I think is referring to the Lower East Rift Zone. Rachel asked about the SO2 in the air recently.
Mm-hmm.
And this kind of comes back to one of the explanations that we've been talking about before, is that the weather conditions heavily impact your ability to smell the volcano fog from Leilani and around Leilani. If it's rainy and overcast and the pressure's high, it keeps the gas nice and low, and you can smell the H2S at really, really low, like trace levels. You can still smell it. right? So I've definitely, it rains, we get some southern winds, the pressure's high with the overcast, and I can smell it pretty consistently.
Interesting.
When it's a nice and clear day and it hasn't been, socked in for a few days worth of rain, then it's, can't smell it. It's just pretty consistent along those lines. You can see it like what we've been looking at is the H2S monitoring GV, and really doesn't vary that much. It sits right around 0, and sometimes but my point is, if you were to go to these vents, the H2S release would be higher than these areas. It's just you'd have to be right at the source to detect it, basically. Trace amounts, but can still smell it.
Yeah, we do have the monitors for the PGV station online here as well. Here's the H2S PGV noise levels. This is online for anyone to see as well. And this report levels, there's nothing unusual. Of course, there's no reason to think anything's happening down there. So I'm just going to just to show you guys that there's that does exist.
Yeah.
There's another question about magma. Just real briefly about magma and water. Since we did open a little bit, that cracked the door a little bit on that. It's worth mentioning that every eruption that happens through the volcano has come up through the water table at some depth, right? So that's why you often see steaming before an eruption or the beginning of the eruption, right? And so the question of how the water is distributed is maybe the more interesting way to put the question, rather than is there water there or not, because there's almost always water there, but like, how's it distributed? Is it all ponded in one spot? Is it all percolated in the rock? Is it in lenses in the rock? Is it kind of spread everywhere? And so that's the interesting thing about it right there. So
yeah, we'll try and do another update to talk about the dynamics of water lake having magma come up under it or pour into it, or some variations along that lines, if as we get a little closer to that being more.
All right, we got some late breaking news here. Late breaking news: USGS has released a statement, and I'll read it to you guys here. Volcano is not erupting. Increased activity increased below Kilauea between November 29th and December 3rd. Ground information rates accompanying the earthquake had a brief excursion from trends observed in past several months. Other monitoring data streams remain stable. Seismicity and ground information rates have since decreased. Monitoring streams remain stable and show no signs of increased activities. That's the summary. The observations, I'll kind of go briefly over it. HVA recorded 80 earthquakes beneath the summit, about 4 miles southwest of Volcano. It began late on the 29th after 11 p.m. and for about 11 hours. In a cluster about 1 mile wide, 1 to 2 miles below the surface. On December 2nd, increased activity began again shortly after midnight and ramped up 4 hours later to an average rate of 10 to 12 earthquakes per hour. HVA recorded over 220 earthquakes for the entire 24-hour period. These earthquakes occurred in clusters under the Kilauea caldera and Upper East Rift Zone at 1 to 3 miles below the surface. This is the same thing as we just showed you guys, yeah?
Yep.
These shallow earthquakes have not posed a hazard from ground shaking. The largest event was a magnitude 3 earthquake. We did not mention that. Yeah, 3.3, 3.1. Those are the highest magnitudes of that of that sequence.
Right.
Bulk of events are less than magnitude 1. Most have not been widely reported. Weak shaking. Let's see. Tilt meter. On evening December 2nd, summit tilt meters experienced a transient episode of deformation, recording a notable tilt signal 10 to 14 microradians within a few hours. Tilt meters have since returned to measuring tilt rates similar to recent months. Other monitoring data streams for Kilauea, including gas and imagery, so no signs of increased activity. So it'll be summarizing what I've showed you guys for the last hour here, you guys, right?
Yeah, and it's great because they put this out 15 minutes ago.
Yeah.
So they're fully aware of what we're talking about here.
Other monitoring data is, increased activity, clustering in the region is not unprecedented following the end of the eruption. It does not mean the eruption is imminent.
Right.
So the seismicity demonstrates that magma continues to be supplied to the Kilauea shallow magma storage system. Right, and that's the conclusion we came to as well.
Yep.
So as of afternoon of December 3rd, seismic activity and ground information rates have decreased and returned to near background levels. Everything is stable again. So, yeah.
All right.
Yeah, one thing we
like the justification for the green too is return to stable.
Return to stable, yeah. So we'll see, yeah. Stable. I mean, it's worth mentioning. If we kind of look at the earthquake maps, like they reported that earthquakes were elevated back in June. They said summit upper east rifts and earthquakes are elevated beyond background levels. Clusters beneath the summit that began in June, right? So here we are. It's been haven't happened quite constantly, but it's been happening frequently, and it's happened frequently again over the last couple of days. So that's an interesting aspect right there.
It's cool for them to put out the second update as well, because they already released one earlier today. Didn't really get to dive into any of this stuff, so
right.
They got it out there. It's relevant right now, which is good.
Awesome. So that kind of ties a bow on that whole part of it, right? Like that's kind of the localized signal. Maybe the ground slumped over near Kahuna a little bit, and it just affected that one rim of the volcano. Maybe the magma is pushing the block that's below the cliff over there, and that's why it's only affecting that part of the volcano. Whatever it is, it's localized just that one area, and it seems like it's stabilized. Stabilized being elevated activity we've seen since June, which is still, what we're saying, pressure building from magma coming into the volcano, right?
All you can do is really watch and wait at this,
right.
See what changes, what doesn't change, what trends come, what trends die off, things along those lines. So
right.
we're just, again, doing the super preliminary stuff, and it's cool to now have something, to actually reference what we're talking about.
Yeah, the breaking news for you guys, just like that. Yeah. So we're gonna end it off. I know we've been going on for over an hour now, you guys, but we're gonna end it off with something fun. This is a story about Pohuiki that Dane's gonna tell us about measuring temperatures down there and how the water has changed down there. So over to you, Dane.
Right. Yeah. So with the Pohuiki hot ponds, or these warm ponds, they formed, the majority of them, like all except for one, formed after the 2018 eruption. You can see how the sand created these sealed in pools, right? And they rise and fall with the tide. So there's about 6 of them in that area. And they've always had these little springs that come into the area that feed into them. And these made them the warm ponds, right? And these springs are kind of anomaly, but they're consistent between Pohuiki and Poho. Right, and they've always been around body temperature, as far as I can remember. A little less. Sometimes they were actually lukewarm, right, some days, but they get up to about body temperature as a maximum until recently. So after the first COVID shutdown, I went back down to Pohuiki when it was reopened, and there was noticeably hotter water. I mean, I got in expecting it to be lukewarm, like I remembered it, and it was a hot tub. It was a literal hot tub getting into it. So that, and then Scott Malice put out a post on Tracker that's like, guys, the stuff's hot down here. It's like he was saying that he was seeing 105 degree Fahrenheit temperatures. So we started recording some temperatures down there. We didn't have a good base. We didn't have our own baseline, but USGS had done some measurements down there. Basically what we're saying, between 34 and 37 degrees Celsius, which is below body temperature. Right at below body temperature, and you can see the location of these ponds. There's 4 of them here that we sampled that are newly created 2018 ponds, and one in the back that is the old Pohuiki warm pond. That's the best name I got for it, and I've asked. So each of these, like before on the first bay, which is labeled with the number 3 here, I never knew that there was really springs there because you had the open ocean washing in there, right? And you can really tell it was warmer there because of how much water was moving in and out of there so rapidly. But since they've been cordoned off, right, we've been able to see a little bit more of these springs in the variant zone. So yeah, I went down, got in it 100 plus degrees, right? And it was across most of these ponds, or all of these ponds. And we might have caught the very beginning or the very end of the heat increase with the first measurements on August 2nd, but we were late on our samples. But from there, you can see that it held since August to late September, or late November, that it's at above 100 degrees, up to 106 at the springs, above the springs at the surface, as measured by an infrared thermometer. It's definitely hotter in this area, and it's just one of those things that was noticed, and then we went and started investigating. And from there, we started trying to figure out why was this increase now? Because one of the things about it is there was no real increase in temperature at these springs following the 2018 eruption. They kind of just stayed the way I was. That's why we weren't following them, is because it just stayed the same until recently, until that 6 months ago or 5 months ago.
Right. So just so you guys know, like this full report is on HawaiiTracker.com, and you can look at the map and all the data. I know that you guys no one can probably read any of this information on here, right? So I kind of to give you guys an example. At the boat ramp on the first day, August 2nd, 97 degrees Fahrenheit. 14th, 103, 20th, 100, 102, 103, 104, right? As one example.
And, like there's a whole bunch of little factors, but the thing, you're looking for that big trend, overall trend of what's happening. And it was a change in there. Stepped up several degrees, right? And then consistently held at that temperature.
Your hottest temperature was 106.
Right there, and the one behind it.
And the one behind it. Yeah.
So yeah, those are some hot suckers nowadays. So if you want to go into the explanation of why we think that, how did it take 2 years for the heat to increase at Poiki following the eruption?
Yeah, I mean it's really interesting. We've had to kind of dig back into some of the old hydrology and geochemical studies, and there are ways that you can date water, actually, right? Put an age on how long water has been flowing underground, right? And so these kind of studies will use isotopes of hydrogen, right, in water, deuterium, tritium, to tell the elevation and residence time of the water underground, right? And so they're basically saying that the water coming out of Pohuiki Springs is falling, between sea level up to about 500 feet elevation, mostly kind of to the west, right? So towards Leilani, that's kind of the basin of Pohuiki. And it takes it somewhere, according to their models, their best guess is 18 to 20 years for that water to circulate from that spot through the ground to actually come out the spring of Pohuiki. 18 to 20 years. Right, so that's a long time, So we're saying that the water itself isn't actually moving from the rift zone over, right? It's just that the source of the heat for this water has always been there, and it's actually been something that's been discussed in studies, right? And so we've kind of compiled this image here, which is a conceptual cross section from two different figures, right? From geothermal discussions, right? So they actually drilled a well. HGPAA was one of the first ones they drilled. An interesting thing is that well went through this hot, brackish thermal water out the bottom and then found cold seawater at the bottom of the well. And so that was why they had to kind of come up with a model of what's going on in an area like this. And they basically came up with this schematic model where we have all these lines in here. These are all different dikes that have injected. We're kind of looking on edge of it, right? All the different blades of lava that have gone into the rift zone, right? So the south flank is this whole zone over here to the right. And they're saying that this is basically a big heat source, this East Rift dike complex, a big heat source. And the water table, here's another line here, is this water table. This is how far down the surface of the ground is right here. How far down you need to go to reach the water. The water actually comes up to the rift zone. It ponds up along the north edge of the rift zone. Actually, there are ponds, around Pahoa area, right, because of this effect. And it actually drops down and is much deeper south of the rift zone. Right, so the water coming out of Pohuiki at the Pohuiki thermal spring is a combination of some rain that falls on here, but there's not a big amount of area. But mostly it's this kind of hot brine, which is getting heated by the rift zone and moving sideways over in that direction, right? And so the water itself might take 20 years to get here, but the heat, it's like a radiator. The heat's moving through the water faster than the water is moving. And there's more heat in the rift zone now for the first time since 1955, 1960. Put magma through that same area upstream of Pohuiki, near where we believe the water source is coming from. It's the first time in that long, decades, right? So, in that sense, 2 years seems kind of fast, right? We might have thought, 2 years seems like a long time for a signal to actually arrive from that, eruption all the way down to Pohuiki, especially considering there was lava like literally a stone's throw away. Right, but it's more about the path of water near the rift zone underground to the deeper part in that brine.
Yep,
So
exactly.
that's the most likely explanation. It really is going to take a full repeat USGS study where they actually sample the water and do all the isotope studies, measuring the temperature, salinity, like all the different factors of it that we've discussed that were done back in the 1990s to set the baseline, right, for a new study now post eruption. So
Right.
that's like the last little nuggets, kind of ruined it with this really complicated diagram here. I'll put it back to the pretty area of Pohuiki here at the end.
Right. One person asked about the sand there, and it's still, washing in, but nowadays it's not sand that's washing in as much as rock. They're from just the bench or these little benches of the lava delta collapsing and washing into the area with the tides, the dominant tides. So now you have hundreds of yards of sand rock mix until you get to the shoreline, which is just rock.
Yeah.
Like that's just what the shore is. So getting in and out of the water, not that easy. It wasn't easy before when it was sand. Now it's really not easy.
Well, I see one last question that I can see. There's about New Lava didn't intrude past the Laini Estates, did it? We're not super far, but we do think it went farther east to the Halekamahina area, right? Enough to push out the Fissure 17 magma. It actually mixed with a little bit of the Fissure 18, and so there was some part of it went that far down, a little bit farther to Halekamahina, but there was most of it came out through Lake Lining. That's true.
Right in the beginning of the 2018 earthquake or eruption sequence.
Yeah. So another question coming in from Jennifer Myers. When we expect to see more earthquakes before activity starts up? That's absolutely true. We have seen a lot of earthquakes, but they're not still at the threshold of 1,000 an hour, or 1,000 a couple hours that we really need to show a magma moving towards the surface in some real concerning way. And even then, we expect that's going to happen most likely in a national park and not anywhere down the lower East Rift Zone. There's no sign of anything in the lower East Rift Zone to kind of summarize things off. Everything's upper East Rift Zone. In the past eras of similar situations, you might have had eruptions in the upper East Rift Zone. Mauna Ulu might be in range. Makapui might be in range, possibly even Pu'o, but I would doubt anything further than that without a whole lot more other stuff happening first, right? So we keep our eyes open for that, but there's no sign of that. Is there anything else you can see, Dane? Questions?
Does the fissure show any increased temperatures or gas releases? Not really, no. I haven't been measuring them with the thermometer nowadays, but I've just been going out there, and every once in a while I was out there Fissure 8 earlier this week and was out in some vents that I hadn't been out to before, but they were still right around that same temperature that I'm used to seeing for certain instances. Right? If it's a heavy steamer, you expect it to be 160, 150 degrees, somewhere in that range. That's kind of what it was feeling like in those areas. Pretty consistent, probably just the standard die-off. There is some adjustments still going on. Steam will start coming out of a crack that it hasn't come out before, but it's about a few feet from the previous crack that was coming out of. Stuff like that. Overall, not changes.
All right, thanks for the questions, you guys.
Yep. Next week we'll try and do one for talk a little bit more about what's happening, what's developing, or what doesn't develop. If there's any changes that are worth diving into, like we thought this one was, or if we're back to the standard background levels. So hold from there.
Yeah, for sure. Yeah, if you're one of the people who have made it to this part of our broadcast, an hour 15 minutes later, then you'll be interested to hear. We'll be trying to do this a lot more frequently. Right.
Right.
So thank you guys.
Right,
Hello.
thank you, Phil.
Yeah, thank you, Dane. Yeah, and we'll report back to you guys next week. Mahalo. Aloha.
Right.